Ladies and gentlemen, John Hammond, Lustre Core Engineer at Intel. He's going to talk to us about layout enhancement, which is one of the features that OpenSFS has paid good money for a design. John Hammond, you the man.
Thank you. It's just like right arrow until I find it?
Yeah, more or less.
All right. There we go. All right. Thank you for having me here to talk about this. I'm going to talk about layout enhancement, which is, as Steve pointed out, a OpenSFS funded design. Go openness and OpenSFS. Also, the committee said that they wanted talks that were applicable to a wider, more inclusive Lustre audience, so I'm happy to say I'm only going to be talking for 15 minutes. It's a little dry, but let's try it. So I'm going to say what layout is, why we're enhancing it, the types we're adding. I'm going to talk about composite layouts and layouts for widely striped files. What is it? It's file striping metadata. So in Lustre, we stripe file data over one or more objects, and we do that for bandwidth and capacity. So it's analogous to RAID 0, but with objects instead of disks. The layout describes this, and it includes things like the stripe size, how much do we write before we go to the next object, or go back to the beginning of the list, the number of objects, the pattern, which to date has always been RAID 0, the name of a storage pool, and then the identifiers for the objects themselves. So this has worked pretty well for us. How do we represent it? Well, it's just a structure with some fields. It has a magic, which tells us what layout type it is, the pattern, which is RAID 0, and the stuff I mentioned on the last slide. And we store this data as an extended attribute, trusted.lov, of the file on the MDTI node. So it's also something you can get from the file on a client mount. And so if you do git stripe, you're retrieving that value and formatting it and printing it. Let's see. So the why, the main why of layout enhancement is to support file level replication, which Jinshan's going to talk about, I think, right after me or right after Mike. So as a means of getting to file level replication, so instead of RAID 0, we have RAID 10 or something more elaborate. We're going to construct the replicas from existing files. And so we're going to construct a replicated layout from the existing layout formats. So a layout to support replication is a composite or container layout, so to speak, that just holds, unreplicated layouts in some order. It also allows us to do something called extent-based layouts. So we could have different layouts and different object sets for different regions of the file. So you have the first megabyte on SSDs, and you have the rest of the file on larger spinning disks, say, if you want it, or however you'd like to do it. But that's going to be something that the composite layout format will support, and then it's up to another project to implement that. But we're just sort of getting some future proofiness now. The other reason I think to enhance layout now is for very widely striped files. Eventually, we run into some limitations based on the fact that we're using extended attributes to store and handle layout data. So there are various limits on the sizes of an extended attribute, but at the highest level, at the POSIX level, we have a 64 kilobyte upper limit on the size of an EA. So that means that we are stuck somewhere at around 3,000 stripes. I don't know if that bugs you or not. Most people probably don't have 3,000 OSTs to carry 3,000 stripes, but other limits like the maximum OST count, 64K right now, that would give you a 1.5 megabyte layout. So I don't think we have to worry about that soon. So now a little bit about the design itself. Jinshan made this awesome drawing, which I really liked. I don't claim that it explains it very well in this context, but it is a very good drawing. So we have a new layout type, LOV comp MD V1. So this is the V1 composite layout type. And it just gives us a simple way of bundling the simple V1 and V3 layouts together. So we say we have this many V1 layouts, each representing a replica of the file, or each representing an extent of the file, or some mixture, and we just describe how they live together. To this, we need operations to add, move, remove entries from a composite layout. So you think of this as adding or removing replicas from a replicated file. So you beef up the replication or reduce it. Finding the entry or replica that you want, or with some property like finding a non-stale replica to satisfy a read, or finding all the stale replicas so that you can refresh them. And then the compact layouts for widely striped files. This is, I think, an idea that's been around for a while. I first learned about it from a Xyrotex Architectural Priorities white paper. So this is, the idea here is to have a distinguished set of object IDs so that we can just describe the objects belonging to a file by just specifying a bit mask of OST indexes. So we have, in this layout, we have stripe count and size as before, and then we have some way of describing the sequence of FID sequences. All the objects share a single OID, and then we have a bitmap of OST indices. So instead of instead of 24 bytes per stripe in our layout, as we have with LOV, MDS, MD, V1, and V3, we have a single bit per stripe, marginal cost. So we pay a little more at the header. We have about a 72-byte header, but we save, when we start to scale out. Yeah, so working in HPC, working at TAC, I felt like every Intel slide deck needed to have a graph with no units on it. So there's the one.